today. Today we're looking at vector applications. A wind is blowing from the northwest or the southeast can be represented by a vector. So we're taking the vector operations and we're applying it in a real world problem. For this, you have to know your directions on a compass. Now the mnemonic device to remember the compass directions is never eat soggy waffles, but it's north, east, south, and west. Okay, it is starting somewhere up in the northwest, and I'm blowing down into the southeast. Now I want to make a point of telling you for vectors, I can move this line, and as long as it stays the same, the vector is not changing. So just to help you see the picture here in a minute, I'm going to move it down to the origin, but it's the exact same line. Okay? This has an eastward component and a southward component. To the east, this is blowing 5 miles per hour. To the west, it is blowing 15 miles per hour. Now this question asks me, in what direction is the wind blowing east of south? So in this right triangle, I can find theta here, but that would be south of east. I don't want south of east, I want east of south. Well, how do I find that? I'm looking for this number here, and I'm going to find this by taking 90 degrees and subtracting my theta measurement. Okay? All right. So, theta is equal to the arc tangent, because I have opposite and adjacent, of 15 over 5. My question mark to answer the question is equal to 90 degrees minus whatever arctan of 15 over 5 is. So arctangent 3. You type this in a calculator, you're going to get a result of 18.4 degrees. This question is finished. Quick reminder, if this had asked for the magnitude, what I would be doing is taking the hypotenuse, finding it, Pythagorean theorem, but C would be equal to, my magnitude, would be equal to the square root of 5 squared plus 15 squared. You would type that in, you'd get your magnitude. And it would be in miles per hour for this problem. That's not what the question asks for this one, but it will ask you for magnitude in the next two problems. All right, go ahead and try these two problems, and that is all that I have for you today. Have a good rest of your day.